Hi, I'm Quinlan, and I was honored to be asked to write an invited review on animal models of cerebral palsy for developmental medicine and child neurology. I invited many esteemed colleagues, collaborators, and trainees to participate in this review, some of whom are here with me today at the American Academy of Cerebral Palsy and Developmental Medicine in New Orleans.
So to kick it off, I'm going to ask some hard clinical questions. CP represents a very diverse array of symptoms and complex comorbidities with varying etiologies. How is this reflected in the animal modeling that you do?
I think the diversity of etiology that you see in the clinic should be reflected in a diversity of animal models that we use in the lab. So I think the diversity of signs and symptoms should be present, at least to some degree, and easily quantifiable in the animal models that we use.
Very good. How do you account for the critical timing of brain development and injury in the animal compared to the human?
In the rodents, like mice that are pictured here in their timeline, brain development at postnatal day 10 is equivalent to a term-born infant. So injuries that might model CP typically are delivered before postnatal day 10, but can often be delivered after birth. So in rabbits, we have perinatal brain development, a little bit more similar to humans. So when we inflict a hypoxic ischemic injury in rabbits, that's actually done prenatally, and that can mimic a third trimester injury.
Very good. Now, Buma, to an easier question, but equally challenging. Since motor symptoms are the key to diagnosing cerebral palsy in humans, are the motor impairments comparable in the animal models? And how do you attempt to correlate these with the common data elements?
So what we're trying to achieve with this work, or some of what we're trying to achieve, is encouraging people to think through how you might assess symptoms or signs like spasticity and dystonia in animals the same way that you would assess them clinically. So for spasticity, for example, before we even get into the sign, we can think about general movements. How is the animal generally moving in an open field? You might think of that analogously to doing something in the clinic like a GMFM. We can also do qualitative assessments of spasticity in animals, similar to how you might think through a modified Ashworth scale. We can develop specific equipment to allow us to measure torque, to assess things like the modified Tardieu scale, and Dr. Quinlan and colleagues have developed a torque meter to do just this. And then when we think about spasticity, we think about increased reflexes. So though we can't take a reflex hammer to an animal model, we can measure increased reflexes electrophysiologically in a quantifiable way. Now, when we think about dystonia, we don't quite have the same quantifiable metrics available clinically that we might with spasticity. So that really challenges us as translational researchers and as a field to develop more quantifiable metrics of dystonia in people so that we can directly translate those metrics to mice, which is what we've done in my lab. Think through how we can quantify leg adduction, variability, and amplitude, and then directly translate those same measures to mice in functionally relevant tasks like gait.
Megan, do you take into account translation of the ICF, or International Classification of Function Outcomes, and can you provide the example with chronic pain?
Sure. From the animal world, where we go and we have very quantifiable measures of pain, where an example is the von Frey test that's shown here on the right. You can see that this is a schematic of a rabbit that's 1 day old, and we actually can apply different types of stimuli, mechanical or thermal stimuli. In this case, it's a cat whisker like monofilament that we apply to the surface of the paw, and we can get a number, a quantifiable number of their paw withdrawal threshold, and that indicates what's a painful level of touch sensation. What's really important to know, and where the animal models become valuable, is they actually give us an opportunity to reverse translate back into the clinic, and we can ask, instead of asking our patients maybe on a scale of 1 to 10, what's our pain? We can actually get a quantifiable number that's more relatable back into our experimental models. One thing that's very interesting when we think about pain is that it's very complex and it's multidimensional. And so the experience of pain can't just be measured in numbers, but it also has components of, affect and mood. And, we all know how much pain can just be really devastating. And so one thing we can do knowing that is coming back into our animals is we can start asking questions and be a little bit creative in our testing and our analysis of our animals and asking them, putting them in situations where they could experience more anxiety or more challenges related to those affective and mood related symptoms.
Very good. From the clinician's point of view, my take is don't be afraid of research, but I want to wrap it up with Uma to give us the take-home message.
There are 3 important takeaways that we want to leave people with. One is to use consistent terminology and assessment criteria across animal models of CP that make clinical sense. That takes us to the second takeaway, which is think through how we measure things clinically using tools like the NIH Common Data Elements. And 3, our third point is we tend to focus a lot on motor signs when we think about cerebral palsy in people and in animal models, but it's really important to think beyond that. And that's what our community partners tell us, to things like pain, sensory impairments, cognition, and beyond. So we really hope that people think through how to make animal models of CP clinically relevant and measure clinically relevant and community relevant outcomes in animal models going forward.